Ninja ZX7R is the successor to the ZX7. In this video, we will explain the differences between the 1995 ZX7 and the 1996 ZX7R, as well as the differences between the 1996 ZX7R and the ZX7RR. First, let's look at the differences between the ZX7 and the ZX7R. The new ZX7R features a new engine with a shorter stroke, higher RPMs, and greater output. The outer surface of the dual headlights is now flush with the fairing to improve aerodynamics. The fairing was designed to emphasize the large ram air intake ports. The most innovative of its many new features are the opposed 6-piston front disc brake calipers. The all-new 748cc water-cooled engine is similar to the ZX7's, but its stroke is 3 millimeters shorter, and it produces higher RPMs and greater output. The old valve train used a rocker arm system. It was replaced by a direct actuation system. This required a change in some components, but the basic layout remains the same. Now, let's look in greater detail at the changes made to various parts of the engine. The ZX7 uses a single ram air induction system. The ZX7R features a twin ram air induction system that provides greater volumetric efficiency. The 4 carburetors are an improved model of the KHI CVKD38. The new carburetor assembly has a center pulley unlike the ZX7's carburetors, which have a side pulley. This change has stabilized engine RPM at idle. Let me explain how this mechanism works. Several microns of clearance are provided between the carburetor body and the throttle shaft to allow for rotation and sliding. This clearance translates into greater play in the butterfly valve as the number of carburetor units arranged side by side increases. Any difference in play between butterfly valves leads to variations in the quantity of air being taken in, which can cause unstable engine RPM when idling. Although the simplest way to reduce the amount of play would be to reduce the clearance, less clearance would be hard to machine, might hinder rotation and sliding, and would raise production costs. So, the cumulative amount of play has been reduced by moving the pulley to the central position. In addition, play has been further reduced by adding an auxiliary return spring that forces the throttle shaft against the engine side of the carburetor body. This reduction in butterfly valve play has led to a smaller difference in the amount of air taken in between each carburetor unit, resulting in more stable engine RPM when idling. The cylinder head intake ports have been straightened to increase volumetric efficiency. The old valve train was the rocker arm type. It has been changed to the direct actuation type to accommodate higher engine speed. The tappets and shims are the same as those used on the Ninja ZX6R. No change was made to valve diameter or valve stem diameter, but the valve bottom surface has been flattened, which reduces its area and allows the valve to stay cooler. In the ZX7, oil from the camshaft must use the notch in the washer face of the cylinder head bolt and the bolt hole as a passage for returning to the sump. In the ZX7R, a large oil passage has been provided to facilitate the return of oil to the sump. In addition, the crankcase and the cylinder head are linked by a passage to equalize pressure. This makes it even easier for oil from the camshaft to return to the sump. In the ZX7, the included valve angle is 20 degrees. In the ZX7R, with the direct actuation valve train, the angle has been increased to 25 degrees. Bore and stroke in the ZX7 is 71 millimeters by 47.3 millimeters. In the ZX7R with a shorter stroke, it's 73 millimeters by 44.7 millimeters. The compression ratio remains unchanged at 11.5 to 1. The pistons are the conventional type. The connecting rods are the same as in the ZX7. Because of the wider bore, the cylinder has been changed from the open deck type to the closed deck type to preserve rigidity. A rubber damper has been installed on the right side of the cylinders to reduce the cam chain's noise. The overall length of the crankshaft is just about the same as in the ZX7. But the ZX7R's crankshaft is more rigid, as is evident from the reduced distance between the crank journal and the crank pin, as seen from the end. In the crankcase, ribs have been added to the area around the output shaft, and the walls have been made thicker to improve rigidity, which reduces frictional power loss. The shape of the splines on the transmission's input shaft and output shaft have been changed from square to involute, like those in the ZX6R. This change means less play in the gear teeth. The number of gear dogs has been reduced from 6 to 5, improving shift feel. The ZX7's transmission output shaft rides in a single row bearing. In contrast, the ZX7R uses a double row bearing to increase load capacity. The outer race of the output shaft bearing has been pinned to prevent friction between the crankcase and outer race, thereby improving the durability of the outer race. The ZX7's clutch center bearing is a plain type. In contrast, the ZX7R uses needle bearings to reduce frictional loss. The digital igniter is designed to keep water out when the bike is being washed or is in the rain. Specifically, the connector is fitted with O-rings to make it more waterproof. Water is introduced over the flange of the cylinder liner of the closed deck design for greater cooling efficiency. The opening temperature of the thermostat has been changed to release the pressure on the water pump earlier to reduce pumping loss. The set temperature for the ZX7R is a relatively low 60 degrees Celsius. For the ZX7, it is 82 degrees Celsius. The oil pan is 30 millimeters deeper than on the ZX7, which increases the oil supply and helps prevent air from mixing with the oil during a hard acceleration. The oil pump rotor is 6 millimeters narrower to reduce mechanical power loss. The oil pressure relief valve for the ZX7R has been changed from the ball type for the ZX7 to the plunger type, the same part used on the ZX6R, to stabilize oil pressure and reduce noise. The oil cooler is an 11-stage core design for greater cooling performance. This type was included in the 1995 race kit options. The ZX7's oil cooler is a 9-stage core design. The ZX7R's exhaust system has been changed from the ZX7's 4-into-1 configuration to a 4-into-2-into-1 layout. A balance pipe connects the number 1 and number 4 exhaust pipes. This improves the exhaust pulse effect, which in turn increases torque in the low to mid-speed range. The silencer is the same size as on the ZX9R, and its smooth internal surface doesn't restrict exhaust gas flow, so engine torque is increased. The perimeter frame is aluminum, as is the case with conventional machines, but beam width has been increased by 5 millimeters for greater rigidity. The front fork of the ZX7R is the same raked type as that of the ZX7, but it features fully adjustable suspension with 8-way compression and 12-way rebound adjustment. The fork inner tube has a larger outer diameter and a thinner wall to increase rigidity. The rear shock absorber is equipped with a piggyback reservoir containing nitrogen gas. The rear suspension is fully adjustable with 20-way compression and 4-way rebound adjustment. This is the first Kawasaki machine to feature disc brakes with opposed 6-piston calipers on the front wheel. The calipers on the ZX7R have a smaller piston diameter, but more pistons. As a result, the braking effect is greater for the same brake disc diameter, and therefore the same brake fluid pressure produces greater braking force. Another difference is the leading piston has a smaller diameter than the other pistons. There is a good reason for this. When the brake is applied, the pads move against the disc, and as the disc rotates, torque acts on the pads with point A as the fulcrum. This phenomenon is called the servo effect. If the force with which the pads are pressed against the disc is not uniform over the disc, sufficient braking force may not be obtained, or the pads may wear unevenly. So, to cancel out the servo effect, the force with which the leading piston acts on the disc has been reduced by decreasing the area of the part of the leading piston to which brake fluid pressure is applied. In other words, by reducing the diameter of that piston. Now let's take a look at how the ZX7RR differs from the ZX7R. First, the ZX7RR breathes through 4 KHI FVKD41 flat slide carburetors. The FVKD41 carburetor helps deliver 4 to 8% greater horsepower than the CVKD carburetor of the same bore, because it has no butterfly valves. The ZX7RR has closer transmission gear ratios to make it better suited for racing. The ZX7RR's clutch plates use a paper-based lining that is more durable than the cork-based lining used in the ZX7R. In the ZX7RR, the flywheel mass has been increased to prevent rear wheel spin when cornering. The ZX7RR's cam chain sprocket has a different shape for ease of removal. Gusset plates have been added at the connections between the mainframe and crosspipe. The ZX7RR's rear frame has been reduced in weight because the machine is not designed to carry a passenger. The steering stem on the ZX7RR is aluminum, while the ZX7R's is steel. The front fork on the ZX7RR is provided with 28-way compression and 13-way rebound adjustment so that the fork can be fine-tuned. In the ZX7RR, the upper bushing of the inner tube in the front fork is fixed to the outer tube. The inner tube of the ZX7RR is steel, so the bushing is in contact with steel and is subject to less frictional loss than in the ZX7R, which is aluminum. The front fork of the ZX7RR is fitted with a rubber damper instead of an oil lock piece. This increases the effective stroke. The rear shock absorber is fitted with 20-way compression and 18-way rebound adjustment so that it can be fine-tuned. A low-speed compression valve has been added to improve low-speed damping. The rebound side orifice of the ZX7RR shock absorber has a temperature compensation mechanism that takes advantage of thermal expansion of the aluminum rod. The front calipers on the ZX7RR are a posed 6-piston Nissin. The pistons are 3 sizes: 30 millimeters, 25 millimeters, and 22 millimeters. The battery for the ZX7RR is an 8 amp hour, which is smaller than the 10 amp hour for the ZX7R. Now you know how the ZX7RR differs from the ZX7R. For information on maintenance, please refer to the service manual.